You're not going to want to miss this episode of the AI Show. Where we talk all about RAG at scale with Azure AI Search. My friend Vinod, make sure you tune in. Hello, welcome to this episode of the AI Show. We're talking all about RAG at scale with Azure AI Search with my friend Vinod. How do you doing, my friend?
I'm doing great. We had a great build conference just last week, and announced a lot of cool new features and a lot of cool customers. And so it was a pretty exciting time for us.
So, for those that don't know, I want to dive right in here. That if they don't know what Azure AI Search is, can you give us a little bit of a kind of a tiny introduction?
Absolutely, yeah. I mean, so Azure AI Search, of course, is a search product. Search, or what's known as information retrieval, is a category that's been around literally for a few decades. And then Microsoft, in particular, has invested in search at the consumer, at the enterprise level, and others for quite a while. What makes Azure AI Search kind of interesting and kind of exciting right now is that there's this big, broad new use case for search, which is retrieval augmented generation, or using search to feed data into large language models, which then go on and perform other tasks. Right. So classically, what people have experience with is search inside of SharePoint or OneDrive or whatever, where it's an end user kind of directly consuming search results. With Azure AI Search, we're leaning heavily into the idea that a lot of search is now going to be intermediated right between the user and the search engine by an LLM. And so, as a result, the name of the product, Azure AI Search.
And it's a really good pattern that solves a lot of issues. Can you walk us through what that pattern looks like?
Absolutely. And so the basic idea, the phrase that's kind of taken hold in the industry is something called retrieval augmented generation, or RAG. And the gist of RAG is basically that when an end user is asking an AI based application a question about a product, or a question about some content, or a question about their health insurance policies and so on, there's some orchestration layer or some application layer thing that says, aha, this is a question that might be better answered by giving the LLM additional data. So data that might be private data inside of the enterprise, or private data inside of other repositories, and then asking the LLM the question. And so an orchestration layer, something like LangChain or Llama Index and so on, forks the question and asks the retrieval system, hey, do you have any content that might be relevant to this question? Retrieval goes out, pulls the content back, and the orchestration layer kind of combines the content plus the original prompt or the original question from the end user, and sends that entire package to the LLM to answer the question.
It's a really useful pattern that makes it really easy to use these things as developers. How does Azure AI Search help in this process?
Sure. Yeah. I mean, the utility of the pattern is, there's no question it's amazing, right? Like I would estimate that something like 70 to 80, maybe even more, of all enterprise AI, enterprise LLM use cases that I've certainly seen involve some level of retrieval augmented generation or some level of RAG. And so I think this is going to be a very common, almost as typical or almost as common as using a database. Is going to be using a knowledge retrieval system when you're sitting with an LLM.
Yeah, and I'm looking at this slide because my very next question was going to be, all right, how much can you actually put in there? Because obviously there's only so much space you can put into a prompt. But if you want these things to behave intelligently in a general way across a wide swath of knowledge that you store, how much can you actually put in there? And I think this answers it a little bit.
Oh yeah, absolutely. I mean, this is one of the things that we were announcing at Microsoft Build last week. There's many, many dimensions of scale, and maybe if we take a step back, right? I think one of the interesting things, and it's been fascinating journey to be a part of inside of the industry, is LLMs and RAG and so on, right? They only really burst onto the scene about 2 or 3 years ago, depending on the Chat GPT or GPT-3 or so on. Most of last year, right? Most of 2023 was really about experimenting with RAG and trying out different RAG workloads. What we're really seeing this year, and what a lot of the announcements we put out at Build, is that we're now seeing RAG going out into large scale production workloads, large scale use cases. Maybe one of the biggest of them all, of course, is OpenAI, and we announced OpenAI's use of Azure AI Search to power their own internal RAG services, but all the different Microsoft Copilots as well, right? Copilots inside of Office, MS365, Copilot Studio, and so on. They all use and maybe most recently Windows, all use some variation of RAG to drive core end user behavior. Um, And so, with all that context, one of the things that we've been investing in heavily inside of Azure AI Search over the past couple of years has been scaling on a couple different dimensions. The one that we're talking about here on screen is scaling in terms of vector capacity or retrieval capacity. We've announced a series of major new upgrades to our products and services that enable you to get something like 10 to 12x the vector retrieval capacity and throughput on a given instance of a server than you had before, right? At no increased price. And this is just kind of reflecting the need to grow with where our customers are growing. In addition to that, there's a lot of work that we're doing around shrinking the size of vectors or giving you more dynamic control over the size of vectors. As the content that's being retrieved and being served to these large language models goes from being, say 5 or 10 or 15 shots or 5 or 10 or 15 examples of content up to potentially hundreds and very soon thousands of examples of content and being retrieved from a database that used to be in the terabytes, but as very quickly as we get into things like data lakes and so on, becomes petabytes of content. You need to scale in that dimension as well. And so both things that are pretty exciting for us.
And with that expanded capacity, are your data types changing? Because I know you have a lot of data types. Tell me about that.
Sure. I mean, so one of the beauties of retrieval augmented generation across the board, and like this next generation of enterprise search, is as a result of as a result of the technology known as embeddings, right, where we create this vector representation of an underlying piece of content. You now get a lot more capability to support a lot of different types of content. And so classically, enterprise search was primarily a text phenomena. But now with vector embeddings, it's just as easy to go and search images, search videos, search different types of encoded text. So, for example, searching an invoice as if it was just a piece of text versus searching an invoice as if it was a structured piece of technology, structured piece of text, right? An invoice has a specific schema associated with it, and so on. And so, all of these different permutations of content are things that Azure AI Search provides fantastic support for.
And this is cool because I mean I know we talk about the Azure OpenAI embeddings, but there's other embeddings too that you can even make more targeted, smaller, larger, whatever, to make things even better.
Correct. And so within Azure AI Search, one of the things that we do, and one of the just long-term investment streams for us is going to be systematically meeting your data where it is in all the different types and formats that the content is. And so one of the things that we were excited by that we announced inside at Build was support for retrieving content directly from OneLake. And so via OneLake, of course, is maybe one of Microsoft's biggest investments outside of AI. And so OneLake is kind of serving as this collection point or the single access point for all of an enterprise's content, regardless of what application created the content and what cloud the content is resident in. Right? There's shortcut connectors to things like Amazon S3 and GCP and so on. We're able to ingest content directly from OneLake and ingest that content in a variety of different formats. And so classically text and documents, but also images, media, and so on. One of the things that we've also done is we've provided pretty amazing support for a variety of different embedding models. So both Microsoft's own internally developed embedding models, as well as external embedding models by our partners such as OpenAI, as well as a very large audience of open source embedding models. And so based on the different representations that these embedding models present, you've got a whole slew of options, a whole slew of ways for how do you get that content, make it available to search, and then represent it inside of search for use by your AI-based applications.
Yeah, and this is absolutely awesome. For those that are wondering, like what is the actual process for vectorizing these kinds of things?
Yeah, I mean, so content vectorization is maybe a fancy word or for saying a fancy way of describing content preparation. When you're doing a retrieval augmented workload, there's usually 2 or 3 steps involved in making the content understood and parsable by the search system. Then once that content's parsable and understood by the search system, it's now servable to the LLM. And so understanding and parsing that content is usually multiple steps. There's usually a variety of different places that content can come from. So, for example, things like OneLake, a variety of different formats that content might be in. So, for example, the content might be inside of a PDF file, but inside of that PDF, it actually might just be the product of a flatbed scanner. And so, a whole bunch of images that happen to be inside of a PDF file format. That content usually needs to be OCR'd. That content needs to be spliced and chunked into different components and different elements. And there's a whole variety of different chunking strategies that the industry has come up with. And probably a new chunking strategy comes up a couple times a month at this point.
Right.
Once you've kind of identified how you want to chunk that content and kind of identify key ideas or key elements of that content, vectorization of the content is now how you provide context. Is how you say this is a piece of content. This is a piece of content that contains the word hello. This is a piece of video that contains the word hello. And this is an image that has the word hello. And how do you make sure that all three of those end up with similar vector embeddings? Is this process of vectorization? Once you have all those chunks, it now becomes, you now add it to the index and you do a very similar process to understand the queries coming in order to match queries to the appropriate vectorized object.
And this is just an awesome process, but is it one that you can do continuously? Here's an example, and I know the answer is yes, but I mean, what if there's like a file that's been added or a file that's been removed in one lake or whatever your data source is? Do you have to redo the entire process? Is it incremental? Tell me about that.
Absolutely, yeah. So the short answer is yes. It is incremental. We provide, at every single level of the system, we provide both automated techniques for handling things as well as kind of developer-oriented APIs for touching and managing and tweaking these parameters. And so when you're doing integrated vectorization, which is basically saying, "Hey, Azure AI Search, you take care of this for me," especially if it's a rich service like OneLake, Azure buckets, Azure storage buckets, and so on. We have a variety of techniques that we do to optimize the end-to-end flow, such as incremental change tracking and doing differential updates to our index. We also provide a bunch of APIs to the developers directly, so they can either set up either pull or push sources for content, and so they can explicitly push new types of content into the index and into our vectorization pipeline, or tell Azure to go pull content from a bucket at some periodic, at some period, and then that it gets added to the index.
I mean, this is amazing. I know you mentioned Azure OpenAI briefly. Can you tell us more about what it is that they're doing?
Sure. And so OpenAI, of course, is one of Microsoft's key partners in the AI race. They're a producer of frontier models, and so things like GPT 3.5, GPT 4, their most recently announced model GPT 4.0. All these models are kind of pushing the frontiers of what AI can do, and they've kind of generated a lot of excitement and interest in the industry. Obviously, retrieval augmented generation is one of these core benchmark use cases. And when OpenAI was designing the retrieval augmented generation pipeline, retrieval augmented generation system, they actually did a pretty open search across the industry to figure out what their solution should be, and decided on Azure AI Search to kind of power their own retrieval augmented generation service. And so this is a quote from them talking about how, as a result of the scale that we provide in terms of capacity, they've now 500x the storage limits they make available to their own customers when it comes to how much content and knowledge they can upload to the OpenAI service. Azure OpenAI, which of course is a version of OpenAI's models that are available inside and wrapped in the security of an Azure tenant, they get access. You're only one click away from enabling Azure Search against your own Azure OpenAI use cases internally.
I mean, and this is awesome. I know there was also a video. So you okay if I play that?
Go for it. Let's take a look.
All right, let's do it.
At OpenAI, our mission is to make artificial intelligence both accessible and safe to all of humanity. ChatGPT has been the fastest growing consumer app in all of history, with over 100 million weekly active users. Our API is trusted by over 2 million developers worldwide.
We launched 2 RAG-powered features. GPTs lets users build custom versions of ChatGPT that have external knowledge. Over 3 million GPTs have been built on the platform. That's a significant amount of retrieval-augmented generation, or RAG, that is happening daily.
The Assistants API lets developers build their own AI-powered assistants to integrate external knowledge using RAG at scale.
To successfully support our massive user base, we need to use the best technology available. That's why we decided to use Azure AI Search and Azure Cosmos DB.
Azure AI Search is more than just a vector database. It is a retrieval system with hybrid search capabilities and support for metadata filtering. Our API users can now upload 500 times the number of files that they could earlier, and that's powered by Azure AI Search.
Azure Cosmos DB auto-scales to meet our capacity needs while being enterprise-grade in feature set and security.
The Azure stack has been very reliable and has worked really well to support our scale needs thus far. OpenAI and Microsoft both deeply believe in responsible AI. With Azure and our tools, we can solve some of the biggest problems of today and tomorrow.
All right, that was amazing. And so OpenAI is using Azure AI Search to scale out, just like you're suggesting that we should be doing. Is that correct?
Absolutely, yeah. And I mean, once again, if it, I mean, OpenAI is absolutely the forefront of what's going on as that AI at this moment, and their customer base has just exploded. And so, we're very excited that we're able to join in that growth and kind of keep up and help feed that growth.
Amazing. Well, Vinod, where can people go to find out more?
Absolutely. So the fast way to learn anything else you want to learn about Azure AI Search is AKAMS/Azure Search. You'll see easy, quick ways to go try the product. Lots and lots of documentation, both for developers as well as for administrators. Sample code, different configuration cookbooks, and everything else.
Yeah, and then there also is a blog post that right below you can go and take a look at some of the innovations that happened as of recently as a build. So thank you so much for being with us, my friend.
Absolutely, appreciate it, Seth. Thank you.
And thank you so much for watching and learning all about RAG at Scale with Azure AI Search, my friend Vinod. Thank you so much for watching, and hopefully we'll see you next time. Take care.